In the last video, I've talked about how when a charged particle moves through a magnetic field, a uniform magnetic field, how this particle would go around in a perfect circle. Right, assuming of course that there is no friction slowing it down. It will go around in a perfect circle because the magnetic force always stays at the right angle to its direction. Well, let's look at an example. Let's try some calculations for this circle. Well, suppose that I want to try and calculate the radius of this circle. Okay. Let's say that's the center of the circle. That's the center of the circle, and I want to find its radius. I call that R. So I need some example values for the object and the velocity and the field. Right. I'm going to take as for example, that's the magnetic flux density is 1 Tesla. For the object, the charged object, I'm going to take as an example a hydrogen ion. So I'm not talking about a small glass ball anymore. I'm talking about an atom. I'm talking about a hydrogen atom. Now, a hydrogen atom, let me describe this a little bit, has a proton, just one proton in the center, and it has an electron that goes around it. Okay. Now, a hydrogen ion, which we normally represent as H+, a hydrogen ion is a hydrogen atom that has lost its electrons. So an H+ is essentially just a proton. It's just a proton in this example. So we call this a hydrogen ion. Ion means an atom that has a charge on it because it has either gained or lost some electron. So in any case, for this example, I'm going to talk about hydrogen ion, which we can just take to be a proton for our purpose. Now, if I'm going to imagine that this positive charge is a proton, we would also need the mass and the charge of this proton. Now, a proton has a mass of 1.66 times 10 to the power minus 27 kilogram. That's a very, very small mass. But even so, it is almost 2,000 times heavier than the mass of an electron. So it has a very small mass, and the charge of a proton is the same as the charge of an electron. They are equal and opposite. The charge of a proton is 1.6 times 10 to the power minus 19 coulomb. Okay, so let me just clarify this. So this is the mass of the proton, and this is the charge of the proton, which I represent by Q. Okay, so there we have the mass and the charge of this, and I should also need the velocity. The velocity, I'm going to take it to be, well, protons are very light particles, so we can make them travel very fast. So for this example, I'm going to take this to be say 10 to the power of 5 meters per second. 10 to the power of 5 meters per second. So that's 100,000 meters per second. Really fast. It's moving really fast. Okay, so that's the example that I would use, and I want to calculate the radius of this circle when a proton at this speed moves through this 1 Tesla magnetic field. So how can we do this? We need an equation. As always, we need an equation to relate these quantities to the radius of the circle. Now, for circular motion, we have learned in a very early video about the centripetal force, and the equation for centripetal force is given by let me write it down here. It's given by F is equal to mv squared over r. So that's the equation for centripetal force, and that relates the force to mass, velocity, and radius, which is what we want. But we also need an equation that relates the force to the magnetic field, and that we have learned not so long ago, a few videos ago, and that's given by F equals to B Q V. Now you might remember a sine theta as well, but we don't need that because theta is 90 degrees. Theta is the angle, if you remember, between the magnetic field direction and the velocity. In this case, the magnetic field, you see that I've represented the magnetic field by dots. That means that it's coming towards us out of this paper or this table, whereas the velocity is going to the right. So the field and the velocity are at right angles. Okay, so this is the formula for the magnetic force. Now if you look at these two equations, the way we understand this picture is that it is the magnetic force. As this charged particle, this proton, moves through the magnetic field, the magnetic field gives it a force. And it is this magnetic force that causes it to move around in a circle. And that also means that the magnetic force is the centripetal force. It's that force that causes it to move around. Therefore, the centripetal force and the magnetic force must be equal. If they're equal, we can make another equation just by equating the two right-hand sides of the equations. So let's do that. Okay, so B QV, the magnetic force, must be equal to mv squared over r. The centripetal force. Now remember that I want to calculate the radius. Looking at this equation, the radius is here. This is what I want. And if you look at the other quantities, I think we know all of them. We know that B is 1 Tesla from there. We know that Q, the charge of the proton, is this value, same size as the charge of an electron. We know V is this 100,000 meters per second. We know M, we know the mass of the proton as well. So we know all the other quantities and we want to find R. So it should be possible. So let me start by rearranging this equation to make R the subject. So I would move R to the other side by multiplying both sides by R. So on the right side, I'm left with mv squared, and I'll move this whole lot bqv over to the other side. Just divide both sides by bqv. So then we have what is basically a formula for R now. And we can, before calculating, we can simplify it a little bit, because notice that we have v squared on top and v at the bottom. So we can cancel a factor of v. So v squared divided by v is just v. So that makes it a bit simpler. So now we are ready to go. We are ready to put in the numbers to find R. Okay, let me do it here. There's a bit more space perhaps. Maybe here. I'll write it down here. R is equal to m is this one, 1.66 times 10 to the power of minus 27 times v. Okay, v there is 10 to the power of 5 meters per second. Divided by b is the 1 Tesla, and q is here, 1.6 times 10 to the power of minus 19. Okay, so what's the answer? Now I just for this example, well, we can calculate using a calculator, but just for this example, I just need a rough answer just to show my points. So I'm just going to say that 1.66 is quite close to 1.6. So if I cancel them, I would get an approximate answer, and that would be, let's see, so it's just the powers of 10 we need to deal with. So we would get 10 to the minus 3 of a meter. Okay, and 10 to the power minus 3 of a meter is the same as 1 millimeter. So that's my answer. That's the radius of this circle when I have a proton going through this 1 Tesla magnetic field.